exploratory search is basically coming from a concept which is often referred as a in the era of big data. It is often referred as a data exploration, right? So data exploration is basically nothing. It is basically a search behavior or a searching tendency with unfamiliar domain naturally and uncertain possible search goals. So this whole thing is captured in this term, which is called data exploration. So let's take a new view. Okay, now in this slide, I have placed all those knowns unknowns again and placed in this green area on each box. I have placed the various type of search behaviors. So you can easily find out this known knowns box is having lookup search again, right? So whatever fact searching we have performed in Google search is referred as a lookup search. We can have fact verification, fact finding, simple search, information search, or informational search. So all those kind of behaviors are kept here, where user basically knows about his information need and the possible expected result also, right? Similarly, on top of that, where we are placing unknown knowns, where information that user have but don't know they have. So here we are placing a very important application area of information search, which is called question answering system, right? Examination, known item search, and review inspection specific. So this kind of behavior which basically requires some kind of cross examinations. So we have some kind of information, but we are not able to spot that information. So those kind of system may be placed here. But my interest in the fourth block, where both parts are unknown, uncertain, right? So here we have placed broadly 4 behaviors, very precisely. So first part is called exploratory search. Similar to that, we refer to as a discovery kind of search. Browsing is one behavior which keep in this block, because browsing is basically nothing. It is plus basically going into a directional search and basically seeing into all objects. So scanning all objects possible on the path. So it is kind of behavior. It is browsing. So browsing does not basically involves any kind of focused search. It is just looking at all the possible items which are coming in your path, right? Similarly, there is a behavior which is called navigation search. So all kind of behavior which do not have clarity or certainty in search goal and clarity and certainty on the possible expected results are kept in the 4th quadrant, right? So in the bottom, we have other kind of search behavior, which is called evaluation, investigation, analytical search, and transactional search are part of this, right? So here we have placed all various kind of behaviors, such behaviors into different 4 quadrants into 2-dimensional again. Now, so let's understand this part, which is called exploratory search. This term is appearing from the very first slide. So let's typically define it. Let's typically identify it. What is the actually exploratory search refers? So exploratory search is basically a phenomena, basically which is contradictory to your lookup search naturally, and it will work for all possible scenario where your lookup search is not working. Lookup search is having some kind of limitations, so you can design a system which will support those kind of search behaviors, right? And the possible reason for this search is naturally the conception of data exploration as a new search dimensions. This data exploration basically raised with the so in the year particularly when we have started discussing about the big data thing, this data exploration basically arises because when we have huge amount of data with no certain feature, no certain specific volume, and no certain kind of system designed onto it, so we need some kind of exploration, right? So like suppose if you are searching for diamonds in a mine, you need to explore it. You need to explore it means you need to search in one direction or a random direction by having some kind of interest, but not have a certainty. So this data exploration thing is closely related to the big data. So the students or the experts who are working in this direction of data science. So whenever we have to design a kind of search system, this data exploration will have a close relation with that, the search system and the data science, right? So the basic tendency in a data exploration or exploratory search is to user will be searching or interacting with the system in kind of iterative and interactive fashion. So user will be placed in a close proximity with the basically search system. Now, as a generic definition of exploratory search is, it is basically, it is about efficiently extracting the data, even if we are not having the idea about what I am looking for. So again, this whole thing is repeating from the first slide. So let's go to the next slide. So here I'm basically drawing a orthogonal view of the three important dimensions. The first dimension is basically the dimension which we are familiar, like awareness of meta knowledge, awareness of the domain which we are looking for, domain of your domain information need. And second dimension is basically this level of prior knowledge of search context. So level of prior knowledge is nothing but it is the knowledge about your search need. So from the same example, if you are looking for some articles for machine learning, so what is my need, what I'm looking for, so how much awareness of the topic I have. So this dimension emphasizes that part. This dimension emphasizes what is the other things I know about machine learning, meta knowledge. So meta knowledge is placed here. Now this third dimension is nothing but it is the facility provided by the current search system, right? Because we are going to implement a system which will facilitate this kind of scenario where user is not having any idea about his search need and his search possible results. So third dimension is nothing but it is the depicting or illustrating the possible support a system is able to provide to the user, right? So this direction emphasizes the support for exploitation and exploration. Now, here we are again introducing two terms for the search scenario or search system to be built on a search system, which is exploitation and exploration. So exploitation is nothing but it is kind of behavior where we are able to apply some kind of focused search. So it is like opening a book and going into a particular paragraph. So suppose you have a book of machine learning. Now you want to understand something about classification technique, something about clustering technique, and within clustering technique, you have to go to some kind of specific technique. So it is like going into a specific focused topic. That is kind of exploitation. We are trying to exploit some kind of detailed or bottom level information. That is kind of exploitation behavior. And exploration, contradictory to this, exploration is nothing but it is the capacity to browse all types of book about machine learning. So suppose if you apply a search list of books of machine learning. So suppose you browse all possible books, browse and select few books. So this is a one kind of exploration. You are exploring, you are not digging into it. So you are simply exploring the titles or the books for machine learning. So basically, so this direction is important. So how much your system is able to achieve in these two behaviors, exploitation and exploration support to the user search in these two dimensions, right? So you can understand that. So in this direction, exploitation and exploration, a system might have capability to basically to simply retrieve the database content, right? The system is able to provide some kind of visual list of objects, visual kind of features to explore into it or to exploit the data. And system might have, at the maximum level, system might have some kind of capability to provide data and query exploration, right? So these are the three levels of these two behavior support from system side. And there are two levels of users awareness on semantics. And here we have other 2 levels or 3 levels of users knowledge about the prior search, right? So these dimensions are important to understand that what is the user's current status, current state, and what is the capability of your search system on these two behaviors, right? Now, so basically, whatever behavior, search behaviors or search types and users state of knowledge state. So based on these behaviors, these types of behaviors, there are two fundamental frameworks are available. Frameworks are nothing but it is a conceptual design of some behavior, right? And these are coming from the fundamental literature of your fundamental literature of the domain actually. So they have emphasized on two behaviors. The first behavior is this, and so whenever user is conducting some kind of play with data, the system is basically capturing the user's behavior and modeling it to again the next retrieval actually. So any student can design a system which is having this adaptive or interactive GUI, and this is one possible and important direction into it. Okay, going to next. So now basically we are actually we are in with the first part of presentation. Now we are beginning with the second module of the presentation where we are emphasizing one important direction. So basically we have discussed various aspects of a search system or search process and users knowledge state. Now we are emphasizing or we are underlining the different facets of a user search, right? So now let's assume that basically I am going for searching something into internet, right? So basically to begin our search, you will be applying. So here we are emphasizing the user action actually. So to start my search, I will be actually focusing on my remember action. Actually, how much we can remember, how much we can recall. So this part user action is nothing but it is a cognitive process which your brain applies, your actually mind applies to the search process which you are applying for searching for some information, right? So to start your search, you will be more or less rely on the remembering process which is recalling the possible prior knowledge, right? So it will be basically accessing the prior knowledge about the search, right? So based on this state, you will apply your query in the system, right? And after system will generate some result, we are basically having some kind of results, and after seeing the results, we'll start a new cognitive process in your mind, which we refer as a think, right? So think is nothing. So at this position, we'll basically do one thing we'll simply correlate our basic search information need, which we applied through a search query with the results which we have retrieved. So we are basically thinking of the result and the previous query. There is a correlation drawing between these two. So at this state, we simply apply our thinking process and the experience which we had and the experience which we gain right now after looking to these results. And after this state, so we are basically moved from remembering the previous information to now thinking state based on the experience gain or the experience gain. Now the next stage is what? Is to imagine. So after looking at the current set of results of the previous query, we will start imagining what is the possible result, what will be the possible result, what will be the possible set of result system will retrieving. Now, for this, we will use the cognitive process as imagine, and so this cloud box represents that there will be the n number of directions. So after looking at the existing results, we can have some kind of visualization to the n number of results. Now, to elaborate this, we have drawn a diagram which is called uh, search context theory. So we are assuming if for a search task we have three states, and each state represents different user mind behavior or cognitive behavior, different states, different processes. So why not to model these three as a three different contexts? So context is nothing. Context. So context is referring to three aspects. First aspect is user cognitive behavior and state and the time actually. So because if you start this timeline is going towards the futuristic search. So one state is this, which have remember as a cognitive behavior, action, and think as a second, and imagine is the third. So we have referred as a three context theory. So first context is the context which is representing the first behavior, which referred as a pre-search context. This is your first state during the search, where we are simply applying the knowledge by using remember cognitive behavior, right? So and here user simply apply query with some terms, and basically he would be waiting for the results. So after that we are going towards the second state, which is referring to thinking behavior, thinking the section, and basically it will be gaining some experience, and that state will be represented as a in search context. Because so we are referring in search. Basically, we are in middle of the search task. Actually, we are somewhere between. So at this stage, we will be basically reviewing the results, marking some results, and we are saving some results. We are bookmarking some results. We are tagging. We are removing. We are providing some kind of feedback at this. So during this in search, user will be performing a number of behaviors which will be saved by the system for the future retrieval. Now, after this, we are going, or maybe we are preparing for the next set of results. So which we are referring as a pro search context. So pro search means proactively we are actually searching. So if we are imagining the possible set of results by looking at the current results, it will be kind of we are proactively imagining the possible results. So it is referred as a pro search context. So this draws the overall picture of a search task. So we have three states, three equivalent, three search contexts. So now it is very simple to understand the three different states. It is very simple to understand the three possible user interaction and possible algorithms for that. But it is critical to implement it. How you will be modeling the correlation between these three states. How the information from pre-search to in search will be flowing. How in search will be able to drawing the new result sets. Right. So relating these three search contexts is a typical challenge which we have faced, but somehow we have clearly identified the boundaries between these three contexts. Next part is basically to emphasize these three different search contexts. I am basically sharing the three use cases. So you can refer as a use case or a case study. So first use case or first case study refers why this pre-search context modeling is important. And in the case study 2, I will be sharing why in search, where we are thinking, how this thinking part, how is this feedback part, how reviewing part is important to be implemented in IR part. And the last case study, we will be referring why this proactive pro-search context is important to be modeled, right? So let's begin with case study 1, use case 1. So to emphasize the role of modeling this pre-search part. So let's take example again. Typically, this we have referred in the very first second slide. So for let's take like this. So for a classroom assignment by a professor or by a teacher, the students with the superior or better curation strategy will be able to answer within time as compared to other students who are less certain or less familiar about the keyword suitable keywords. So suppose in your classroom, a teacher have asked to solve assignment and give basically provide 30 minutes time to find out the answer of a question. So naturally, if you browse, if you explore the search history of each student and the possible completion time of students, so you can easily understand why some students are able to answer this query or a question in the lesser time, and other students are basically not basically capable of doing it within time. So you can easily differentiate. So one typical behavior is the basically suitable keywords. So the students who are not able to complete the assignment in the time, they might not have the appropriate keywords to solve the question or to retrieve the query. So naturally, it means to get the proper results or the relevant results, uh, having suitable keyword is one key aspect, right? So basically, if you are able to model or maybe apply your query in a proper term, it will give you the result in a prompt time. So it is important to understand the initial search interest. Initial search interest means the initial keyword to the search, right? So here, so this particular scenario, this classroom scenario typically offers one possible uh, uh, direction, which one of you might take as a uh, problem statement for your project. Can you collect the search history of those brighter students, right? Search history of those brighter students, and basically somehow model it and use this learning or this history to assist the poor students so that they can easily spot or retrieve the results. So you can compile the, I refer this as a search thought process. So if you assume that these 10 students are better in their search studies, searching process, you can explore or you can process the search history of those 10 students and model some kind of search thought process and use this search thought process to plug into the search behavior of the other students, and this thought process will help those remaining students to search, so conduct their search more efficiently. So kind of transfer learning you can apply. So right, so basically this is use case, and besides that, to understand the initial search intent, it is important to model the pre-search context carefully, right? So no, okay. So for this, you can the primarily you can design some kind of query completion strategy, like we have discussed. So the search thought process of first 10 students may be used to assist the remaining students in their search completion strategy. So they can easily pick some keywords to apply their search, right? So these kind of system you can design where a kind of supports will be provided to the user to complete or to accurately apply his search interest, right? Next, we are going for the case use case two. So basically here, our objective is to emphasizing the role of modeling in search, right? So is here we are typically taking a use case of so searching for research publication. So let's take one of the research scholar who is looking for some kind of academic article, right? So for some kind of research article, he will be typing some keyword. Then after typing these keyword, system will be suggesting a number of research articles, and by looking at particular research article, he will be again refining it and going for the next kind of search. So this is basically nothing but state where we are discussing in the in search context. So during this uh, case, actually, the information needs are complicated because you are typing a keyword machine learning. Now, after typing this keyword, you will get 100 of research articles, and after looking at to these 100 articles, your interest will be changing, or maybe your search goal will be becoming a more complexer one, because the list may be expanded. So basically what we are trying to emphasize that uh, the behavior at the second stage of search are important for the searching for the search of the next retrieval. So it is important to model all kind of behaviors during the search, so that we can accurately navigate towards a direction. We can have n possibilities, but we eventually user wants to pursue one of the direction, pursue one of the documents, pursue one of the possible list of documents. You cannot go n number of ways. So that's why it is important to capture the in-search behavior, right? So capturing in-search behavior requires some kind of system modeling which can capture the relevance aspect. So now we are introducing the new concept which is called relevance, right? So we might have some kind of familiarity with the uh, relevance term referred as a user relevance, pseudo relevance. So there are kind of relevance concepts are there, but if you are in the middle stage of such process, it is important to model such user behavior. So whenever we are talking about capturing user search behavior, it is talking about capturing user relevance feedback, right? Because during the first stage of the search, when user applied a query, system retrieves some kind of results. So system retrieve results for initial query based on uh, some kind of relevance, which is often referred as a algorithmic relevance, some kind of TF-IDF mechanism, term frequency based, inverse document frequency based mechanism. So all those algorithmic means are referred as a algorithm AR, right? So for the user supplied query, system will fetch some kind of results, and after browsing, after reviewing these results, system will be again capturing users behavior and using this behavior to retrieve new set of results, right? So this behavior modeling is often referred as a user relevance feedback, because user is now actually participating into this part by applying some kind of behavior. In the previous stage he has simply applied a query, right? So it is important to capture the user behavior during this stage. Now we are going to the third use case, where we are experimenting with the user behavior and modeling that experimental behavior for the retrieval of future or prospective behaviors, future results actually. So this typically is coming from a domain which is called evidence-based medicine. So evidence-based medicine as a domain, as a application domain, where a doctor is basically generating a comprehensive report of a patient by observing. So let's take as a patient, someone has given some samples on to our doctors, and that based on some kind of sampling, system is generated some kind of comprehensive assessment report which says the effect of a medicine of a drug during this kind of parameters. So basically it is kind of experimental trial and error based assessment report. So here simply user is applying what uh, some kind of exploratory analysis of the effects of some kind of drugs on a symptom, right? So basically this is typically related with uh, this 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 retrieval process, where we are applying several query with the variable predicates and review the possible effects and again submit the relevance. So it is important to basically the one point which I am actually emphasizing here is very important to incorporate third kind of relevance, which is called pseudo relevance, right? So this is not new concept actually. These search systems like Google search systems and other search systems are applying this phenomena which is called pseudo relevance. So pseudo relevance is nothing, it is a phenomena which basically captures few set of results in the upcoming search iterations. So if you have some kind of, you might have observed that whenever we are searching something in the Google search system with some query, after second, third, fourth, or might be sixth query also, Google is again coming back with us, coming to us with the same set of results. Maybe 3 or 4 results are retained in the sixth search also. So it is happening because of this pseudo relevance feedback, because system is assuming that maybe you have applied 10 queries, but these three or four results, or maybe one result is still important to you, to your search. So relevance relevance feedback is important. And whenever we are designing a system to maintain the role of uh, this pro search possibilities, pro search context, you need to build a pro search or relevance, a pseudo relevance feedback mechanism. Now, to summarize all, actually, when we have discussed this three search context theory, and when we have explored the possible uh, states and other things during the initial first module of the presentation. So these are the basically possible challenges and issues which can take as a maybe research objective for your projects or for your thesis. So we have actually placed all the possible challenges and issues into two different blocks. The first block represents the challenges faced by the user. Actually, user is not having any kind of supports to take care of, or to basically basically address these issues. At the system side, we are having some kind of issues which basically till now the systems are not having to support the user search. So let's take first the problems or the inability at the user level. So in the current systems, there is no supports to uh, understand what are the real information needs. So in current systems are not able to underline or understand, or they're not providing any kind of facility or assistance to the user, so that user can understand, or user can basically get awareness about his information needs. That is one possible issue. Second issue is basically uh, in typical systems, usually not having any idea about basically where to search. Actually, which keyword is basically the most appropriate to start his search, right? So that is what we need. We can build a system which can basically accurately suggest some keywords before beginning the search, or you can provide a number of keywords based on some user previous interest. So this is the one possible direction. Again, it is related to the second point: how to formulate or reformulate data query. So formulating is again the same thing. Appropriately placing a keyword, identifying a keyword which is most close to your search query, close to your search interest. And if you want to rewrite your query, what is the best or most appropriate reformulation of your query? So this is again one area which we as systems are facing. Okay, after getting some results, so after maybe somehow you are able to write some query, and after that system suggests some results. So systems are not having facility to underline or outline that for your search, this part of data is important, not all, right? System might having, so current system are simply retrieving the results, and results are displayed in a GUI, but they are not having any kind of mechanisms to at least highlight, or maybe color changing mechanism arrangements which can emphasize that, which can outline that out of these 10 or 100 results, these are the closer one, these are the small, these are the lesser important, these are the least important. So some kind of arrangements you can have to at least highlight and emphasize, so that the user's effort will be reduced. So he can easily focus on the top 20, or maybe these 4 or 6 results, and he can navigate to the next result, or he can put the. So in the current arrangements, users are simply browsing all the results, because as far as user's perspective, all the results which are displayed in the first page, 10 or 20 results, are equally important. So we can devise a mechanism which can emphasize that out of these 10, those 4 are important, most important, something like that. Similarly, basically, the next point is how to use the result of initial query is nothing but it is related to the first point, where we can emphasize the top 5 results, and based on those 5, it can navigate for the next query. So after assuming that those 5 results are important, system itself can design some kind of query words or keywords based on which user can start the new query, or user can go for the next set of results. So this is kind of query directions, or basically outlining the direction for the next query. So that is the last point which I want to emphasize in user side is when to change the current data source. So basically, uh, if you are searching for some results, uh, so system is just a number of results. So after assuming that the first query result is important, you spend some time on that particular result. So is it possible to devise some kind of system which can emphasize or alert you that this is enough, now you have to go for the next results, right? So because the second result might also have some kind of importance. So these are the primarily observed issues. So you can design a system or interactive system which can enable a user on any of these issues. Now going to the next side, which is limitation and the system side. So so system side means we are actually designing some kind of support to the search system, which may enable users as well, or which may enable user to conduct his search, right? So at system side, it is important, or it is critical to identify that what to read or search by user. So system side again, can we have some kind of algorithm, or can we have some kind of uh, formulation or modeling which can understand basically what to read or what to search. I mean, to understand users' need, we can design some kind of mechanism. Second, basically after retrieving the data, can system have some kind of visualization or outlining or emphasizing a mechanism to basically give an estimate that this portion should be basically placed to users display. Next basically is to some kind of support to the search system where it can predict the path for the next search. So let's take 10 results are displayed, and basically after reviewing those 10, what is the next way to go for, right? So this particularly case is little being solved in the one of the search system which is called semantic search system. There we are having some kind of arrangement to basically outline the possible next search direction. So after reviewing these 10 results, after seeing these 10 results, user can go for the 11th or 20th result in the next screen or something like that. Okay, so next issue is basically how to capture the search intent transition. So typically this is widely addressed by various researchers in a way that so after conducting 6 or 7 query results interactions or searches, systems should able to capture the possible changes in the search intent. So let's take, you are searching for the books and you have engaged or you have conducted n number of searches in a Google search system. So systems should able to basically summarize all those previous searches, and he should be kind of pre-processing it, kind of utilizing this previous search history into narrow down the possible results. So that's what we are trying to say. So systems should be able to capture the possible navigation of his interest, right? So all the possible results, all the past results and previous queries should be used or utilized to navigate or basically model the search interest, future search interest, right? And last 2 points are important. It is important to gain the user. Uh, it is important to depict the what users information gain, and actually is to balance the exploitation and expansion resource. Keeping these issues and challenges, we are going for a little deeper. Actually, so this particular figure is important to understand the overall search process. How we are assuming and we are understanding uh, the overall search process, right? So now we are going deeper into the search process and user state of knowledge, and how relevance mechanisms are being actually modeled. So this whole box, outer box, is representing a real world space, and this inner box is representing the user's cognitive space. What that is, these things are basically happening in the users or our mind whenever we are applying a search. And this box, rectangle box, represents our system, IR system, where we are having in the bottom document collection. So list of all possible documents, and we have processed these documents and derived some kind of object 1 to object n. So So in the bottom, we are having the data is stored, and in the upper interface, upper level, we have kind of pre-processed those documents in kind of objects, data objects, right? So actual documents are kept here. So this is your IR system. This is your cognitive space, user's cognitive space. This is outer world task. So let's start. Okay, right? So suppose a professor has given you the task, any task like searching for the list of books. So in a real world, someone is giving you a task. That task is represented by typically W. This is work, right? So this is what the such task actually the such task which is coming in the real world. Now, after getting the instruction about the such task or the such task itself, we start perceiving it. So whatever instruction we have received from professor, we used to model it or to understand in a way what we are referring is CW. CW is nothing but it is a first understanding of your task. So whatever professor have instructed you, based on those understanding, we have manufactured or designed some kind of impression about the task, which we are referring as the CW. CW1 is the first impression. CW is the cognitive perception, cognitive understanding your such task. Now, so this CW is not enough naturally. So CW is first understanding. Now to apply CW, we basically come up with N. Now N is what? N is what referring as the keyword from your search need domain. So professor have instructed you to find out the list of books in machine learning. Now you need to have some idea. So maybe you are having some kind of remembering a past history, which referred as to search the task or to complete the task given by professor, you need to apply the keyword machine learning, because for the search task, the information you have about the domain, search domain, is the machine learning. You might have some kind of memory. In your memory, you can have some idea about the machine learning keyword. So this N is represented by keyword machine learning, right? So N is nothing but it is coming from your search domain knowledge, actually, the keyword or maybe the perception which you have developed from your domain knowledge within your cognitive space. And now this N will be mapped into user query. So because you have very limited knowledge about the domain, and the limited knowledge is reflected into the query term. In this case, it is a machine learning keyword. Now, you have typed the keyword in the system Q, and based on this Q, system applied some kind of algorithmic relevance which we have discussed, kind of term frequency mechanism, any kind of mechanism, which simply maps your keywords with the objects which we have processed and kept in IR system. So based on this Q, you have mapped with O and derived this result R, right? So this whole journey is coming from W to CW, CW to N to Q, and based on this Q, you have applied some kind of relevance AR, algorithmic relevance, and derived the result R. So this is one way of completing the task, right? So there are one transformation from W to CW, CW to N to R. So we have three transformations of your one or for one such task, right? So now this is one way. Now after getting the result R, you may explore it, you may browse it. So after browsing these results R, you might have some new knowledge, some new experience. Now your CW, after looking at to these R results, now your CW might have new impressions. Now your conceptual understanding about your work may evolve, may change, because you have no idea about new information. So now CW becomes CW2. So CW2 will basically have the mapping in new N. New N is nothing but it is a knowledge about the domain, search